Okay, we're going to start looking at the surface areas of cones, and we're going to do a couple problems that go along with that. But before we get into the surface area of what a cone is all about, there is some terminology that we have to learn. The first one is something called slant height. And if you read this little thing, it says the shortest lateral distance from the edge of the base to the cone of the highest point. What does that mean? Basically, what you're talking about is you're talking about being from the base here all the way up to its highest peak, the highest peak known as the vertex. So we're looking at this slant height here. This is different from the actual height of the cone, because the actual height of the cone would start here on the bottom and go right up here, and that would form a perfect 90-degree angle with the base. That's the actual height of the cone. That's not the slant height of the cone. The slant height is we want to know what this edge is. So this opens up a really, really cool question here, because if you look at this, check this out, baby. We got an a squared plus b squared equals c squared triangle happening here, which is going to really, really complicate things as we get a little bit further on into this. Okay, enough with that. We'll leave that for later. All right, so let's go back to this. So now we know what a slant height is. We have to know also, what does the term lateral area mean? Well, I've got two examples over here that'll probably summarize this quite nicely for you. Here's a wonderful little soup can. Okay, in a soup can, what you're talking about in terms of the lateral area, you're talking about the area of, if you had, let's say, a label around the soup can. That's what you're looking for. That's what lateral area means, is what is the label of the soup can? What's the area of the label? Okay, if you look at something like a pyramid, you're looking at what is the area of one of its sides, or a combination of all four of its sides in this case, in terms of this pyramid. So lateral area is kind of like that area on the side. So if you're talking about a cone now, the lateral area is this area of the actual shape of the cone, excluding the base. Okay, so if you were to do a net here, if you were to cut this cone right down like this, and you were going to do a net, this is what you'd get. You'd get a shape that would look something like this. This is a net of a cone. So you'll notice that it has a nice, beautiful circular base, and also, because you cut it here, you get this kind of nice round, almost like a fan shape here that comes up and goes up that way. Okay, that's the lateral area. That particular one has an interesting formula we'll get to in a second, but you know that the base, being that this is a circle, that's way too easy. We know that the area of a circle is pi r squared. We learned that way, way, way back when we were like in grade 8 or so. Okay, so the area of the base is pi r squared. But what is the area of this lateral face here, this lateral cone here? Well, that has a very interesting formula. This is pi. Why is it pi? Because we are dealing with the radius again. We are dealing with the radius. So it's pi and the radius times the slant height. So let's go back to this wonderful thing right here and see if we can figure out what we're talking about. All right, so here's our nice little radius. Okay, there's our circle. So our circle is pi r squared. Okay, now we have to figure out this lateral area here. Well, the formula for that is pi times the radius, which is still this guy here, times the slant height, which is from here to here. And that's why when you put these two together, the base and the slant height, you have to add these together to get your actual formula. So what I did down here is I put the formula. The surface area of the cone is that base, which is a circle, added to the lateral area. So there's the base, and this turns out to be that wonderful lateral area that we're talking about. Lateral, there we go, area that we're talking about earlier. So the next podcast is going to show you a couple of questions on how to do calculations like with this formula. But I thought this would be a real nice setup for you.